Good afternoon, Professor.
Good afternoon, Amy. Good afternoon, Olsmail.
Good afternoon.
Good afternoon, Nicholas. All right. Good afternoon. Oh, now we're rolling now. Good afternoon, Stephen. Good afternoon, David. Good afternoon, Diana. Good afternoon, Chloe. Good afternoon, Brooke. Good afternoon, Samuel. Good afternoon, Gianna. Top of the afternoon, Abdel. Where'd it go? Good afternoon, Jasmine. Good afternoon, Brianna. Good. You guys are fast. Wow. Good afternoon, Jaylin. Good afternoon, Jamilet. Good afternoon, Shamil. Good afternoon, Shakia. All right. And who else did I said Shamil. Amy, yes. Oh, good afternoon, y'all. Good afternoon, all y'all. Sarah, that's right. The plural of y'all is all y'all. Awesome. Yes. Good afternoon. Good afternoon. I said David. Okay. And Shamil. Okay. Awesome. Good afternoon, all, and good afternoon to my board, which has to be okay. So one logistical thing we have to. So you might have noticed that I've been posting stuff related to help you with a midterm exam, which we do have to have. We haven't really discussed yet when exactly that is. Oh, someone's here. We have to establish that right now. I'll tell you my I'll try to be brief about that. I want to spend the day. I want to spend today preparing you more for. We'll continue with the material and preparing you for the midterm exam and talking about it. But I know we've never actually established a date. Let me just quickly remind you, or remind many of you, and tell those of you who have not been in this class, in my class before, the way the midterm. Well, let me make sure of this first of all. You did see in your Google Classroom that there was a practice midterm document posted there. Yes. Can I get yes? Okay, great. Thank you. Okay. So the way this works, and again, I don't want to spend all period on that. Great. Thank you, Gianna and Abdel and Amy. Thank you. The way it works is that your actual exam will be taken from that practice document. It'll be that practice document is like a rough draft for me and for you of what the actual exam will look like. The actual exam will definitely not be longer than that. It might be shorter in that it probably will involve some choices here or there, so you won't have to do everything. That you have to practice everything and be ready for anything on the exam, but the exam will include nothing that isn't on that practice document and may possibly ask you to do less than what's on that practice document. Anywhere in the document that I do provide any solutions, whether on the web, in a recording, in remote instruction like this, or if I post them, anywhere that I give you actual solutions, you can expect that I reserve the right to make some changes, like to the numbers in I will make some changes to the problems that you actually have to think, and you can't just like literally copy your solutions, but they won't be drastic changes. Your actual exam will look and feel extraordinarily similar to the practice. That's the point of it, so that by the time you get to the actual thing, there's no surprises. It's just a matter of knowing how to do your physics. Also, so again, this is a reminder for some people, but I'm also saying all this. Some of you, I want all of you to know like what a midterm exam looks like or feels like in this class. But even if you already know this from last semester, part of the reason I'm reminding you of all these things too is that when I'm done with this little speech, we're going to confirm the date for this. I mean, it's not a democracy, but I will take your input. And whatever we confirm in a minute is what it will be. So you need to know what it is we're talking about. Wait, something's in the chat. Hold on. Okay. So the actual exam I'm talking about, and there's also there's one midterm exam, and then there's a final exam. I can also remind you maybe later or maybe now about how all the grades work. I mean, hopefully people are getting used to that, but I can remind you how the weighting of the exams work and stuff like that. But the point is that the exam that you'll take will be remarkably similar to this one. Anywhere I do give you solutions, like I'm going to today give you some things that are direct solutions to that exam. Anywhere I give you direct solutions, you can expect some degree of change to the details of the problem, but not the overall structure or whatever. And anywhere that I don't give you any solutions in advance, then you can assume, okay, that he's just going to reproduce that problem. Like if I literally don't give you a solution or say anything about a certain part of a problem, you can assume pretty much that that problem will just verbatim appear on your document. And so you could consider this just advanced warning on what to prepare. Now I say prepare, let me also make clear, and many of you know this, but this exam that I'm talking about that we have to schedule in a minute or two is take home. Just to be clear again, what we have to what's going to happen is at a certain day, I'm going to post the exam itself. I'm going to post it in Google Classroom. It's just as though it were one big assignment that's worth 100 points instead of whatever. And you know, an assignment that's longer than a typical assignment, but I'm going to post it in Google Classroom. Under exams, you're going to, I would recommend printing it out. You're going to take it, you're going to have a few days to do it. You're going to take it in your own time, in your own way, not under test conditions. And you're, as many of you know, you have open universe to do this exam. That is, you can use the web, you can use your notes, you can use, you can go back and look at YouTube recordings of this class. You can talk to other people. You can do all, and you'll know that I will have given you in advance some solutions to some of these problems. So, and it'll be due back. Well, we're going to discuss that, but you'll have like 3 or 4 days to do it. So it's much more like a paper or a presentation or whatever you want to call it, a project, than it is a sit-down exam. I just want to remind, again, some of you know this, but I just want to remind you again that I'm giving you an exam where I know that you know that I know that you have all the resources in the world at your fingertips in order to do it, including some answers from me in advance, and including your friends in the class with whom you are allowed to work and help. In fact, not just allowed or tolerated, but encouraged. So what that all means is not that I'm an idiot. I mean, maybe I am an idiot, but that doesn't mean that I'm an idiot. What that means is that what I'm looking for in your final presentation of this document is just that, a well-presented document. What I'll be looking for is not just that you show me that you have the right answers. That's not good enough. Like we all know, hopefully you do have the right answers. You're going to show me, you're going to treat your exam like a proof, like each problem, like a mini proof or derivation, where you're trying to show using the 5-step method, all the process that gets you from a problem to a final solution. And you're going to be proving not only why that solution is that solution, but you're going to be proving to me that you actually understand it. I've given this speech before, but you're going to give me a document that I can look at on its own, where you have made every question so clear and all the work so clear and the final answer so clear, all on separate pieces of paper, like on blank white sheets of paper, the way we've been practicing the homework, like as though it were a blue book. You're going to, I don't mean literal paper, like you're going to scan it in, but you're going to give me a document that in your way represents all the questions, represents all the work, and represents the final answer circled, all that, so that I can literally mark your exam without looking at the original test questions, so that anybody who understands any physics can follow your exam from beginning to end and evaluate whether it is good, proper, appropriate, convincing, comprehensible, and comprehended physics or not. Your goal is to prove to me that you understand everything that you're writing down. That's the actual exam. The exam is not showing me that problems are solved. The exam is showing me that you literally, by the time you write all this down, have filtered all the understanding through your personal mind, which means the more personal and individual that you make your exam, the better it is. The more colors you use, the more diagrams, the more you commentate on the margins, the more you do it as though you do your own personal note-taking or whatever, the more you show that you get it your way. That's what I'm looking for. Okay, I'm getting carried away as usual. But I'm saying all this so that you know what we're getting at. So in some sense, the exam is hopefully, it's meant in some sense to be less stressful than a typical science exam in many senses. Most of the things that would often count as cheating do not count as cheating in this exam. And the reason for that is in my heart, what I really consider to be cheating is when one person takes an advantage that other people didn't take because they are honorable. Like when one person takes advantage of other people's sense of integrity and honor to cut a corner that they didn't cut, that to me is cheating. But I'm saying to you full on that you are all allowed to talk to each other and you're all allowed to go on the internet and you're all allowed to use your past notes and stuff. So it's a level playing field. And you literally can hold each other while you're like working out rough drafts for this exam and all of that. And I would recommend that you do work out a rough draft for the exam. You can hold each other's hands to the final moment. And then in the final moment, you don't have to write in your exam like Chloe taught me this part or something. No, I don't care. It's physics. No one's claiming that we made any of this physics up. It's not a matter of plagiarism or footnote or anything like that. If Chloe, I'm just using Chloe as an example. If Chloe taught you something right at the last minute that you haven't understood for months, fine. God bless you and Quark bless you and Quark bless Chloe. But by the time you write it down, what you write down is only things that you understand. And you show your understanding by breaking down everything you do into as tiny steps as possible. Anywhere in the exam that you're like, wait, does he need me to show this part? Like I'm dividing both sides by 2. Does he really need me to show that? The answer is yes. Anything that ever occurs in your mind of like, is that a step of work that I need to show? Yes. If you even ask yourself that question, if you can even visualize it as a step, you want to show it. The tinier your steps are and the more of them that you show, the more you're convincing me that it's really your understanding, not your original invention, but your understanding. Okay, I'm getting myself, and I wanted to, I don't know if, whatever, if I can tell the difference. It's like the one thing that is cheating is if you just write down things that you got like from the internet, or so if you just write down equations because you know they're right, but you don't get why they're right or what they mean or how to use them. I know the difference. Believe me, I know the difference. So the more English you can show, the more diagrams you can show, the more you can walk me through your mental process. That's what we're looking for. Okay, now that all that set. So it's a take-home, untimed, fully open exam, okay, which will look very much like this practice that I'm gonna start going back to talking about explicitly today. Okay, right? So the good news is no surprises. You'll know what it looks like. Good news is you can work on it however you want, blah, 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 blah. Then it will be due at a certain moment. You turn it in electronically to Google Classroom at the moment it's due. And I have to be firm about that. That's the one thing we'll talk about that in a second too. With an exam, I am firm about deadlines. If you know you're going to have an issue, like you have a family issue or a medical issue or something, I'm not asking you to prove it or anything like that, but I'm saying you got to tell me in advance. If you reach out to me individually in advance before the thing is due and say, I'm having an issue, can we make some kind of arrangement? The earlier you reach out to me in advance, the more generous I will be in the arrangement. I can make arrangements with individuals, but they have to be arrangements. You cannot surprise me the day of the exam and just like not turn it in for an hour and then an hour late turn it in and expect it to be like a no-brainer. It will not be a no-brainer. Okay, you get all that. Now, that said, okay. Once we settle on the actual date and stuff, what's for the next couple of class, or at least for this class, I'm going to be explicitly talking about the practice exam and try to help you with the real thing. Okay. And then, so when I say we're now going to finalize the date, well, okay. So we're about to finalize the date for it or figure out the date for it right now. That'll take like 5 more minutes. Then I'll get to the material. Before we finalize the date, which is happening in a moment, I'm talking about the date for the midterm. Can I just get a show of electronic hands? Like, do you follow what I'm saying so far? Does it seem to make, okay, that's 1, 2, 3. Okay, cool. Thank you. Cool. Okay, that's a lot. Okay, that sounds like, all right, cool. And I'm particularly also looking at the people like have never had me. I mean, most of you have had me before, but any of you who has not had me before, feel free, please, to write something in the direct chat or text me or something. Like if you're not exactly sure about the rules of this or what I'm saying. And really, hopefully you guys are like friends from lab, like people who have not been in this class before should really talk to the people who have and get the true scoop. Because what I am saying to those of you who have had me before, yeah, it's the same routine as Physics 203. Like I'm not trying to trick anybody. It's the same basic deal. Hopefully I'll get these graded faster than I did in 203. But okay, that said, I'm going to tell you now a different option. Like I will tell you bluntly, originally in my mind, like a couple of weeks ago, what I originally had in mind is that this exam was going to be posted this Thursday, like in 2 days from now, or tomorrow, I mean, and then be due back this coming Monday. Now, I think that, but I didn't warn, but then things happened and I missed class and stuff. So I'm assuming that's a little tight. I'm assuming you wouldn't want that, but that is an option. Okay. One option is that I post this thing tomorrow night and then you have it due back right before class on Monday. That's one option. Just keep it in the back of your mind for a second. Another option is we can have this thing due. We can have this thing. I believe, you correct me on this. I believe we have school this Monday and then we have school again the following Monday and then you go on break. I'm pretty sure. Like, I think we have school April 2nd or whatever it is. You might want to correct me on that, but I believe we have 2 more Mondays and then we're on break. Yes. Okay. Thank you, Sarah. Awesome. Okay. So I'm willing, if you want, to make this thing due the Monday right before break. I mean, I'm not sure that's a brilliant idea for everybody. And I don't know what other exams you have that day, but that's an option, is that it could be due the Monday right before break. If it were due the Monday right before break, I would post it the Thursday before that. Okay, so that's option number 2. Like, just bear this in mind. And I may even walk away from the screen for a second so that you can talk. But option number 1 is that, like, I post it tomorrow, it's due this Monday. I assume you don't want that, but if enough of you have enough other conflicts and you think you're ready, you're certainly welcome to do that. Option number 2 is the other extreme, where I post it the Thursday before break, and then it's due the Monday before break. Also, to warn you, even if I do that, which I'm fine with, if that works for you, I mean, it makes this kind of close to the final exam, but if you're fine with that, I'm fine with that. One thing about that is that we would still go on to new material, like, if not, we would still go on to new material like next week. We wouldn't spend every single day until that time reviewing, just to be clear, but that's an option. And the final option, I think those are the 2 main options. The other thing I could see is if you wanted, if you, well, this is weird, but if it's better to not, I usually give like a long weekend to people to do this, but I could also imagine if you'd rather it not mess up a weekend, I can post it this coming Monday and have it be due back like Thursday night. Is that the same? Thursday, Friday, Saturday, Sunday, Monday, Tuesday, be back. It would be due back Friday, excuse me. So those are 3 options. Okay. The options are, and sorry. Well, how long? How long? Well, okay. Oh, wait, there's a lot in the direct chat. Wait. Okay, and again, of course, I don't want to spend the whole class on this, but I do want to give you guys input into it, especially because well, whatever. I just think it's better if you have some agency over this. There's a couple of questions in the direct chat. Okay, and I'm going to have you discuss it for a couple of minutes amongst yourselves, so you should put things in chat and stuff. Just there's a couple of direct. Okay, wait. So one question in the direct chat is, how long is the exam? Well, I was trying to address at the beginning. It's no longer than the practice exam, but it's slightly shorter. It's the material of the practice exam, but you'll probably have a choice here or there somewhere in it. So it's like 4 big problems, but you'll have some choices involved there. How long would it take to sit down and do it if you really knew your stuff and stuff like that? Like it's probably a 3-hour experience if you just sat down and did it from the beginning to end. But I don't recommend doing it that way. I think you should do like a rough draft and then a final copy, blah, blah, blah. But it's the practice exam is the indication of how long it is. It's like 4 big problems. I would say if you just sat down and did it and gone through it like a timed experience, I would say it's like a 3-hour experience, but you'll have, no matter what, like 4 days to do it. To answer, I'm just answering a question in the direct chat. Also, do the Monday of spring break. That one, I think that gets tricky. If I make it, I think also it's sort of ethically, I don't want to make something due. Like technically you're on spring, once you're on spring break, I don't want to have something due. As far as I'm concerned, the options are the Monday right before the break, or the Friday before that, or the Monday before that. No matter what, you'd have essentially 4 nights to do it. And I'm going to walk away there's other questions in the chat. I also want to say, yes, I'm going to sort of this is not a democracy nor a totalitarianism. Like, I'm going to walk away for a second so you guys can discuss this as a group. I'm not saying it's literally majority rule. I don't want like the majority to oppress the minority or something like that. I want you to have a reasonable discussion for like 2 minutes so that you feel like you're looking out for one another as a group. But I also want to make this clear too. If it ends up that the basic group thinks one thing, okay, and there's 1 or 2 of you that really get your life messed up by that, right? Then the 1 or 2 of you is going to reach out to me and explain that you might need like a little accommodation. And I'm open to that. Okay. That's the point. Like, we're trying to decide right now what the basic system for the group is going to be. Part of my whole thing about all of this is we need to promote more collaboration amongst ourselves and less competition. Although I think you as a group, as I've told many of you individually, and I've written in letters of recommendation, I think you as a group are a particularly special, awesome, collaborative group. I want to just keep encouraging. So what I'm saying is I'm going to walk away from the screen in a minute and you're going to discuss it or in the chat or whatever as a group. But the loud people are not going to like win over the quiet people. If you're a quiet person who's got an issue and the whole group goes a different way, you just later reach out to me individually and we'll see what we can do for you, whoever you are individually. Okay. Like, I really do mean that. That's what we can do that. I just don't want to be surprised by someone just ignoring the deadline. Okay. So wait, I'm going to walk away and say, wait. Okay. And I know, yeah, I'm going to repeat the options. Yeah. Okay. And, I know this would help if I were actually saying them with dates. All right. And I don't mean to take up the whole class with this. This is a mistake I make every time. Okay. Hold on. I'm just going to, in the chat, I'm going to put what the clear options. I'm going to try. Whatever, any option well, it doesn't matter. Right. Well. Okay, I think this is clarifying, and thank you for asking me to clarify. I think if you look in the chat, I think those are the three. Did I just put a, wait. Yeah, and this is a kind of thing, stuff like your quant midterms or whatever is partly why I'm throwing this out to you, and why, even though it's a little weird to spend this much time in class on this, like I'd really rather you as a group feel that this works, you do something that, okay, wait. Okay, and everybody that's putting things in the direct chat, I'm seeing and I appreciate, I'm not going to, okay. And I'm looking at anything in the direct chat and I'm taking it seriously. And again, let me just say, if you put something in the direct chat, I'm taking that as an advanced thing right now. I'm taking it as you're already telling me that you're trying to be honorable and trying to be respectful. Like anybody who's in the direct chat that's already telling me a problem that they have with one of the options, I'm telling you right now that if the group votes for the option that you're already concerned with, who are you guys in the direct chat, if you're telling me about an option that you have a problem with and the group votes for that option, I remember your name. I'm seeing your name right now. So if you just remember, like in a day or two, to email me or text me and say, remember, I had hoped that you wouldn't, blah, blah. Is there a way we can, then we will. And I hope all of you understand that that is fair, because that could be any one of you, if you know what I mean. And it might be a different one of you on the final exam. Like I'm not going to go into a whole thing of why I think that's, but okay. So, but you just can't just like do whatever you want. But all right. So just tell me if do the options look clear and correct to you? Like I did the dates right and everything. I mean, I think each one of them is a 4-day option. Oh, wait. Would not be able to include. Okay. Okay, I see. Complete detail. Okay, I see. If you're saying you're having an issue, I hear you, and you'll just reach out to me, and then we'll do something. Okay, like honestly, I mean, of course, if everybody. But all right, so just tell me one thing. Anarchy. Yeah, anarchy. So all right, I'm assuming that the options are clear. Also, to be super. Oh no, we do have to get this resolved. Yeah. All right, so I'm gonna walk away for like 2 minutes. I don't. Okay. I'm going to walk away for 2 minutes, discuss it, chat it. Ideally, when I come back, I don't care if you guys take a vote or whatever. I'm not going to take a vote. When I come back, maybe you're going to report to me what you think the basic consensus is. Again, knowing that I will respect and accommodate any minority concerns. Okay, I'm walking away for 2 minutes. Okay, I'm back. Wait. Oh. Okay, wait. So. Wait, all right. I have a quick. All right, we should move on. I'm reading all this. I appreciate one. Oh my God. Wait, one thing. Am I right that we go on break Tuesday the 4th or something, or Wednesday the 5th? Wait. We go on break Wednesday the 5th. Okay. But you're saying that quant. The quant midterm is going to be posted April 2nd and due when? Okay. Yeah, because one thing, it's a little bit of it. I hear what everybody's saying. Okay, and the Orgo exam, I definitely understand. The quant is due the second. Wait, the quant midterm is due the second or posted the second? Wait. Well, posted the second. Okay, thank you. All right. I mean, as much as I don't want, all right, here's the deal. I do the 5th. Okay. I'm hearing you. And this is what I was worried about. All right. I hear you. I mean, one thing I could do, okay, and I don't want to drag this out. Here, again, whatever we decide here, remember that then if you have an individual issue, as long as you anticipate it and you get back to me, like, and I'm not saying you have to get back to me like literally like in 5 minutes, but I'm saying like tomorrow or the next day, get back to me. Especially if you get back to me before I even post it, then it's, if you get back to me with a personal issue, we'll work with it. Here's the thing. I'm not going to make it due later. I'm not going to make it due in the middle of break. First of all, that makes me uncomfortable. Second of all, the truth of the matter is when we go on break on Wednesday, if that's Passover, that's a fairly big deal to a lot of people. And I can't in good conscience ask you to make something due like right when Passover starts. Like that's a little intense. What I can do, first of all, I know this is not what you're asking. I certainly can post it a day early. Can I? Yeah, I can post it a day earlier if that helps you. I know that's not what you're looking for. I can post it a day earlier. And again, if anybody reaches out to me and just needs a personal extension that they can't hand it in that Monday, the 2nd, I will work with whoever you are as individuals. I don't want to make it due as an official thing in the middle of Passover or the holiday. But I think what we're saying is, okay, but I'm hearing all this. And again, like I said, I'm taking all this input. It sounds to me like all things considered, your best, the option that you like the most is having it be the latest. The third option is what it sounds like you're saying. Stop me if I'm wrong about that. And all right. So what I can do, and not to make you more nervous, whatever it is, I'm seeing the direct chat too. I will post it for what it's worth Wednesday night. What are we saying? Wednesday, and I'll put this all in the Google Classroom when we're done. I'm not going to spend time on this right now, but I will put it in the Google Classroom Wednesday night. Like I'll put it in a day earlier to give you a day. I know to some of you that just suddenly sounds like it, but you know what I'm saying. I'll post it Wednesday the 29th. I'm copying this. I'll post it Wednesday, so you have an extra day. It'll be due Monday the 3rd. And the other reason I have to make it Monday, well, I'll think about that, but Monday the 3rd. Yeah, I'll make it due Monday. If you have a personal issue, you'll talk to me. But I'll post it a day early, so you have an extra day to do it. You'll have the full weekend to do it. Yes, you'll have but then hopefully you'll have it. If you're wise about it, you'll be able to have it done before even the quant thing is posted. It's not ideal. I don't want to compete with quant, but hopefully this gives you a full amount of time to do it before the quant thing is posted. And if there's a little overlap, there's a little overlap. If you have an issue in advance, tell me. But what I'm going to say right now, in fact, yeah, I'm saying this. I believe that's what I just modified option 3. That's what I think we're saying. And by the way, also part of the reasoning, that means it's due right before you come to class on Monday the 3rd. That's also part of the thing, is to have it be due right before you come to class. Then you come to class. That's part of your responsibility. Again, if you can't, you have to tell me in advance, blah, blah, blah. But you come to class with it already submitted. As long as it's submitted by 12:15, then you're good and I'm good. And then we do other things in class. But you don't just hand it in, you don't skip class and then hand it in, because then all of your classmates see that you've done that and that you've cut a corner that they didn't cut. And and there are consequences of that. Like, it's not fair to look around and see that you killed yourself to get the exam in before class, and then 3 of your friends are just not showing up, and you know they're still working on the exam. And then if you think that I'm going to give them full credit for that, that makes you angry at them and me and at yourself for having followed the rules to no avail. So it's due right before class unless you make a private arrangement with me. All right. Okay. I'm just, and I will post this in Google Classroom, but I know not all of you might love this result, but hopefully it's the best possible result, all things considered. So can I just get a show of hands if you understand and if it's clear what we just decided? Okay, I'm waiting for. Okay. Okay. Cool. I think that's good. Okay. Is that, and Shakia, Shamil, Olsmail, like you get, okay, you're good. Okay. All right. Thank you for working with me. Hopefully this is a good comp, hopefully this is the best maximization of minimization or whatever. Okay. Now, how long did that take? A long time. Okay. I'm going to start walking through the exam now. Now, whether you know it or not, we already have been. Oh, are those questions or those hands up? I mean, are you, okay. Let me alert you. Okay. There's 4 problems in the practice exam. Maybe I'm going to walk through it in a way right now. Hang on a second. I'm going to switch screens. Okay. Right. Okay. So this is the practice exam, right? Partly it's meant to be a rough draft for the actual exam. In other words, if I look out for updates, if I find errors in this or something, if I update this document, I will only do that to make it even more similar to your actual thing. Any update or correction or something I post is to get it to even less surprises on your actual thing. Okay, so if an update comes out, throw out the old and pay attention to the new. This will be the equation sheet. If you don't recognize every equation, don't worry about it. If some of those equations you don't need, that's fine, but you can use everyone that's there. Of course, you can go on the internet anyway. So why do I even post an equation sheet? Partly why I post an equation sheet is to emphasize to you what I think of as GDPs, what I think of as the known or given type of starting points for analysis. Like some things are results. They're not GDPs. Am I expecting you to use the 5-step method? Yes, I am. Do you have to write like step 1, step 2, step 3 in the margin? You don't have to. Would I take off points if you don't literally write step 1? No, I wouldn't. But I highly encourage that you do. It's all you want to do everything in your power to make it as easy for me to follow what you're doing and to see that you know what you're doing. It's only to your benefit and mine if you do actually notate the steps as you go. Please also remember that the steps are the grading rubric. That's where I will take off points or give points is for missing steps and stuff. So the easier you make it on me to find your steps, the easier it is that you've guaranteed yourself in advance that you're getting all the points or just, okay. So that's why there's an equation sheet. Okay. This one says instructions for this practice, do all problems. On your exam, it might say do problems 1 and 2, but choose 3 or 4 or something. It might, I'm not guaranteed. But if it does say something like that, I'm telling you right now, don't do more than what it asks. You won't get extra credit. Don't do, if it gives you a choice, don't do every problem and then expect me to just give you credit for your better one. I can't do that. Okay, so that's that. Then this first problem, okay, you will notice this first problem is exactly homework 3, which I believe we've started talking about. I'm going to go back to and talk more explicitly. Is there even I can't remember if there's a video. For sure, there's an old video on this if there isn't one from this semester, but this is homework 3. And the basic insight to the whole thing, this whole problem comes down to, do you actually get that if they gave you that differential equation, then that value D is oscillating harmonically, cosinusoidally at an angular frequency of 25 radians per second. Where did I get 25? It's the square root of 625. And everything follows from that. If you get what you need to understand about this problem is that that differential equation means that D is oscillating at a constant, is oscillating cosinusoidally and harmonically. What does harmonically mean? It means it has a constant frequency, a frequency that is independent of amplitude, right? Independent of amplitude. That's what it really means to oscillate harmonically, to have a frequency that is independent of amplitude. And specifically, the cosine solution to this differential equation has an omega in it, an angular frequency, a rate of radians per second that is necessarily the square root of whatever that constant of proportionality is, like right after the negative sign. Now, you have to show all that, like you have to put it in words and equations and stuff like that, but that's the insight of this problem, is that we've got an oscillator whose angular frequency is 25 radians per second, the square root of that constant, and everything follows from that. Like once you know the angular frequency in radians per second, you can figure out the standard frequency in hertz, you can flip that and figure out the period, but that's the insight of that problem, okay? And it's just like homework 3 is a good practice for it. Okay, that's like my summary of that. I think I might post more about it, or there might be videos, but that's my summary of that problem. Oh, I got a question there. If you go down to the bottom of that problem, well, I'll tell you right now, like question 3, for example. Well, all right, no, I'll say I can go quick. Question 1 then is, it says how much time will elapse before the very next time. Wait, why is this in? Oh, I'm sorry. By the way, I realize now looking at this. It really should say degrees Celsius. I'm sorry. It should say degrees Celsius. It doesn't change how you do the problem, but it doesn't make sense for it to be Kelvin, because then it could never get to negatives, and it should fluctuate around. So change right now, as long as we're doing this, change Kelvin to Celsius. That's a mistake. It should say Celsius. That's number 1. Again, you'll do the math the same way, but then so question 1 is asking for period. It's asking how much time before the thing gets back to 150K. It's asking for period. How do you get that? You get angular frequency first, and convert to period. Number 2, when it's asking the temperature at the moment precisely 25 seconds have elapsed, you plug into the cosine equation. D equals D naught cosine omega t. Let me tell you, again, when you're solving these problems, like when you go to question 1 of this, do the 5-step method, like you should provide a diagram first, like a cosine graph. You should state the question clearly. But then when you get to step 3, GDP, that's where you should really put your thought in all these questions. Put your thought into the GDP. The GDP for this is something along the following lines. For any variable z, if d2z over dt squared equals negative omega squared z, then C is a harmonic oscillator, which can be described by the expression Z equals Z naught cosine omega t. Now, I know I just said that quickly. I know I'm going a little quickly, but I feel like this is in a million, you can go back and review this and stuff, but I'm saying the GDP is that in general, GDP always means a truth that you would know even before the question started. Of course, a truth that's topical to the question, but a truth that is true regardless of the details of the question. So the truth is that for any variable, call it Z, if that differential equation applies to Z, then Z equals Z naught cosine omega t, where omega is the square root of omega squared, of the constant in the differential equation. So you write that as your GDP, like write it in terms of Z's or something, right? And explain it and say, we have a harmonic oscillator here. I know because of the differential equation says that the second derivative is directly proportional to the variable. The constant of proportionality is the square of the angular frequency at which this value of D oscillates. Like you say something like that. That's your step 3 GDP, is a broad explanation of how this equation works and what it means for oscillation in omega. Then in step 4, you say here the variable is D. Here omega squared is 625. Here, therefore, omega is 25 radius. You see what I'm saying? Okay, so that's what you do. So then you use that cosine equation in number 2 to get the D, the temperature, plug in 25 for T, I'm going to tell you right now, the answer to 3 is radians squared per second squared. You might want to think about that on your own at home. But no matter what, whether we're talking about temperature or a mass on a spring position or a pendulum position, no matter what, the units of omega squared are always radians squared per second squared. I'm also going to pause. I hope this is helpful. I'm choosing to keep this board instead of the other board because I hope you see why. But like, for example, number 3, I just told you the answer. The answer is radians squared over second squared. So, it's possible. I'm going to change question 3 now to something a little similar, but just different enough to think. So just, bear that in mind. But question 4, to get to the whole point of question 4 is it's trying to say, we've studied a mass on a spring for this long because we're using masses on springs as models, as representations or vivid examples of harmonic oscillation in general. What we're now saying is anything that obeys that differential equation is a harmonic oscillator, and it could be as seemingly abstract as temperature. But what we're saying when we say that the math of a mass on a spring applies to the math of a fluctuating temperature system, we're saying that anything in the world that has that differential equation can be regarded as a mass on a spring. Like pendulums on strings behave just like masses on springs. Electric fields that oscillate harmonically behave just like masses on springs. Or PChem. This is all prep for PChem, quite honestly. Subatomic particles that obey the Schrodinger equation, or some version of it, act like masses on springs. So this question number 4 is saying, can we take that really seriously? Like, okay, like let's view this temperature as going back and forth on a spring, or this temperature is going back and forth on a spring. If we give you the mass of the temperature, can you figure out in effect, metaphorically, how stiff this effective spring is? And the answer is yes, you can. And how? To get to the chase, sort of, how? For number 4, the key equation for number 4 here is omega equals square, for a mass on a spring system, omega equals square root of K over M. Now you would show that. You would show that in your GDP, step 3. That's not a memorizer. That you would show it by taking 2 derivatives of the cosine function. Okay, again, I hope you're hearing this. You can play this video again. I know I'm going, but the key equation that you want for number 4 in step 4, number 4, is that omega equals square root of K over M. Therefore, you could square both sides and say K equals omega squared times M. And you just solve for K, and you get this huge number. It's like 10 to the 5th newtons or something. But you got to show where omega equals square root of K over M comes from at least once in the exam. If you end up using it later in the exam, you could say refer back to page 3 or whatever. Okay, you're trying to guide me through all the physics from first principles. All right, so that's how you do number 4. Then lastly, number 5 and 6, just one thing, because someone asked me this in the chat. When it says true or false, blah, 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 is one possible solution to the diffie-q, like this is like that, the homework 2 we were doing. But when it says as well as the condition it means is for which that the initial temperature is D0 equals 150 K. That's what it means. So it's saying, assume both of those truths in the document. If both of those are true, the equation and the condition, like, does that statement solve it? And I'll tell you right now, like, obviously I'm going to change the examples. Like, you can use this for practice if you understand. I think number 5 is true. Well, I think, what did it say, 150? Sorry. Yeah, number 5 is true, and number 6 is false. I'll leave that to you to think through or talk amongst yourselves, but I think number 5 works, and number 6 does not. I hope you understand why. And by the way, I don't mean to be steamrolling questions from the chat. Please put, for some of you, maybe this is finally the pace that you want me to go. I don't know, but put in the chat if I'm going too fast or if I just skipped something. Please do. This is meant, but I'm just trying to. The goal is for this exam to be real, and intense, but not stressful. If you know what I mean. I hope you know what I mean. So okay, now we're going to go to problem 2. Again, I'm just giving you an overview here in case, whatever, I'm giving you an overview. I may do more detailed things later. Question 2, problem 2 is very much like homework 2, right? It gives you a differential equation, then it asks you if a certain thing is a solution. Now, look, again, it might be a little intimidating at first. You might say, wait, we never looked at anything with a K and a Q and an RQ. Like, what is all this nonsense before the X in that differential equation? But please note what it says in the top right. K and capital Q and capital R, they're all constants. So a constant multiplied by a constant divided by a constant cubed is all just one big constant, right? So that thing that is given to you there is the differential equation that we are interested in at this level of the course. It is, it's a second time derivative of X is directly proportional to X. It is negative times a constant times X. So the solution is some kind of cosine solution with an omega that is the square root of that constant. So if you look, and if you've been paying attention, and I'm going to shift gears in a moment. Yeah. If you look, and that example that it's giving you, like, you take that cosine expression that it gives you now, you have to show why it is or is not a solution. What you're supposed to do, what you need to do on the exam is take 2 time derivatives of that, just like you were practicing in homework 2. Take 2 time derivatives and see if you get back, if your second derivative looks like the form of the thing above. And I'm going to tell you right now, if you do it right, it will, right? Because the omega is the square root of the thing above. And then there's this added bit in the parentheses that looks like it's coming out of nowhere. But the whole thing we just explained 2 days ago and last week is that that extra bit in the parentheses is called a phase constant, and it won't adversely affect your derivatives. It's a phase constant. So that thing is a solution. You have to show it in your exam. You've got to take 2 derivatives and walk me through anything that occurs in your mind. You want to write down. By the way, especially one big litmus test is if there was ever any step that you once upon a time did not understand or didn't know was a step or was confused, and then you straightened it out in your mind, that is a surefire example that that's something you want to write down. Like literally something you learned, something that didn't make sense before, but now makes sense to you, is definitely the kind of thing you want to show me, like whether you put it in those words or not. But anyway, that one will work, but show yourself like now. And I want to speed up a little bit. I mean, again, I'm not sure this is the last time we're going through this, but I just want to give you a big overview. That next expression, looks unfamiliar. It's E to the I, blah, blah, blah. Here, that may look intimidating. I'll tell you, you're going to have to use chain rule. We know chain rule. The one thing, maybe you want to write this down right now. I think many of you are familiar, but many of you may have forgotten. A GDP for this, a GDP, a step 3 for this next question is if Y equals E to the X, right? Like I'm going in general now. I'm not talking about this particular physics of X and T. I'm saying in general, as a mathematical truth, if Y equals E to the X, then dy dx equals E to the X, right? I think some of you are familiar. I mean, I think all of you are familiar. Hopefully some of you remember that. I'm saying in English, the derivative of the exponential function is the exponential function. In fact, that's the meaning. Ultimately, that is the deep content of the exponential function. That is, it is the function that is its own derivative, okay? So using chain rule, you can take 2 derivatives of that thing. If you're careful, you can take 2 derivatives. And then you might say, well, what do I do with that I? I is just a number, yo. I is just a number. It's a constant. Treat it as a constant. Why am I throwing it in? Why am I even bothering? Well, I'll tell you this as a hint or whatever. I is just a number. It's the square root of -1. But that's all you need to know. And it says it up here. I is defined to be the square root of -1. That's literally all you have to understand about, all any of us understand about I, for anything else interesting about it to follow. What I mean by that is this, and you may want to write this down. I is equal to the square root of -1. That means by definition that I squared is -1, right? And therefore I cubed is I times I squared, which means I times -1, i.e. -I, right? And I to the fourth is -1, is I squared times I squared. So I to the fourth is -1 times -1, that's 1, right? And I to the fifth must be I to the fourth times I. That means 1 times I, that's I. Now that might have gone too fast for some of you, but here's what but the reason I just did that is I'm saying as long as you know that I equals as long as you know that I is the square root of -1, you can figure out all the powers of I from that directly. And if you write down the powers of I, you can figure them out. You might have heard me just say them, but you can figure them out. And you'll notice a pattern that by the time you go through 4 steps of I, you get back to I itself. Sound familiar? It's just like cosine. If you take a derivative of cosine, you get negative sine. And you take a derivative of negative sine, you get negative cosine. Take a derivative of that, you get sine. Take a derivative of that, you're back to cosine. Oh, so there's some, I'm just saying, what I'm really saying is, oh, there's something in the chat. I will stop in a second. I am talking a lot. But what I'm saying here is, this is the nature of a physics exam. It looks like there's these new things being thrown at you. I promise you, they do look new and they look intimidating, but they're not actually new. The whole point that we're trying to make is you now have a toolkit that is designed to fix problems that you've never seen before. Just treat I as that number and know that the derivative of e to the x is e to the x, and you're set to figure out whatever you need to figure out about this. I'm going to pause for a second because something's in the chat. Hold on. Sorry. Oh, yes. Okay. I will repeat once with I will repeat it, but I won't repeat it 4 times because I think what I'm saying, you could do it on your own, but I'm saying this about I is this. So someone just asked me, so fair enough. I is the square root of -1. That's I to the first power is, and it says it right here, is square root of -1. So therefore, I squared, I to the second power is -1, is square root of -1 times square root of -1. That means it's -1. Square root of -1 times square root of -1 is -1. So I squared is -1. I third means I to the first times I to the second. So it's literally those two results multiply by each other. I to the third is I times -1. So I to the third is -I. It's I times -1. So it's -1 times I, -I. And I to the fourth is I to the second times I to the second. So that means -1 times -1 equals 1. Okay, hopefully that helped a little bit, but I'm saying I'm a little interested in time. So you could text me again if you didn't get that again, or if you want me to do it again. But I think if you just write down, if you just do it slowly, like as long as you know that I is the square root of -1, then everything I just said was just like multiplying that out over and over and over again, if that makes sense. Let me see. Oh, great. I'm glad that helped. Okay, cool. All right, now I'm going to go. So you could do, so these questions, they may look new, but they're not. I mean, they're the same type of thing as before. Okay, then I'm going to say, wait, there's something else in the chat, I think, or, oh, cool. Oh, great. Okay, thank you. What a nice thing to say. Okay, thank you. Good. I'm glad that was helpful. Okay, all right, now the next problem. It says problem 2, first of all, at the top, or it says part 2, hook on a hook. It should say, that's a mistake. It should say part 3. I'm going to tell you right now, partly because we have 14 minutes left, this problem I walked through for 2. I'm not saying it's that bad or anything, but I did a full walkthrough, a full solution of this problem for actually 2.5 hours in the double period in the other class, and I posted a video to you may have already noticed, it's called the pendulum problem or whatever, midterm review, and it's posted already in your Google Classroom. So I highly recommend, so you scroll through it, whatever, but I walk through the whole problem in a video. Please watch it, is all I can say right now. Okay. And similarly with that group, like they didn't get the walkthrough that I'm giving you right now about the first two problems, but they'll see that video. Okay. So between all of you, if you have friends in all different sections, I'm just giving as much as I can to blah, blah, blah. Okay. So watch the video on this. It's in you, and send me questions if you have it on, but this whole thing that I'm scrolling through right now, there's video on. Now, finally, so that's like most of the exam I've just given you at least hopefully some help with. Again, I'm not trying to trick you. I want you to understand this. Like, this is not about hide the ball. It's not about guess what the professor's going to ask. What it is the physics is just hard enough that we want to get ourselves all to the point of actually getting it. If you get it, great, then you should be chill and please help other people. Your goal in the exam is to show me that it actually makes sense to you. And as long as you do that, if all of you do that, then you all get A's. I want this stuff to, while you're studying, I'll shut up in a second, but one of the best things you can ever do while you're trying to get this material is keep looking back to the old material, like stuff from the first week, and try to remember what it looked and felt like then. Like when you saw this stuff, keep on trying to remember what you felt like when you first looked at any of this material, and ask yourself, does it seem to make more sense to me now than it did then? Because if you can find material like that where you remember, I looked at it, it made no sense, but now it makes sense to me, then that's the progress. Then first of all, that means that the next stuff that still doesn't make sense will make sense to you. Like, take confidence from that. But also, like, that's what you're looking to portray to me on the exam. I got to remind you one last time that the weird thing about physics is, to all of us, is that when we look at something the first time, it looks like absurd. It looks like it makes no sense, and we hate everybody. I mean, not always, but like a lot of times, like, we hate the professor, we hate the question, we hate ourselves. We're like, this means nothing. I don't even know what it's asking. Then by the time we get it sorted through and we understand it, then the problem is we all go like, oh, duh, that was obvious. Oh, yeah, well, duh. And then we think like, oh, I was an idiot for not understanding. And like, why is the professor even wasting my time? And by the time we get it, it seems so obvious that we don't even know what to write about it. We don't even understand what anybody's looking for anymore. This happens to all of us, that once we get it, we don't think there's anything to say anymore. But that's not true, because we didn't get it 5 days ago. So what you're trying to show me, like every bit that you didn't want to understand that now you do, that's the thing you want to explain. Like talk to me like you're teaching it to the younger version of yourself. Like, say, you would think that the omega squared makes this you would think that it doesn't make any sense to call it omega squared, but we're calling it that because we know that the square root of it will be omega or whatever. Like anything that you have figured out, that's what you're showing me in the exam. Okay, now why am I saying all that? Because this last question 4, okay, the real answer to this is largely the video of yesterday's class, Monday's class. Okay, whether it seems clear or not. And you should really also try to remember lab 3 and lab 4 is what's underlying this question. But what I tried to do Monday is the video from Monday is the answer to this question. I mean, you have to understand it and put it into your words, but that's what I'm looking for here. And with 10 minutes left, I'm going to remind you right now what I mean. And we might, well, I guess we might still have one more class on this, before you actually take your exam. So it should all work. But even as it is now, you could take this exam. Honestly, I'm going to switch screens. Well, yeah. with 8 minutes left, what I'm trying to say here, what the whole point of this is, if you take a collection of harmonic oscillators, spread them out evenly on, for example, an x-axis, and let them each oscillate in an identical fashion on the y-axis, right? I mean, obviously you could turn around the whole thing, but like, for example, if they're all spread out on the x-axis and they're each free to oscillate at the same angular frequency and same amplitude on the y-axis, but if you stagger their phases by a constant step, then what you have is a wave, right? The ultimate point is that a wave is a collection of identical oscillators, all staggered in phase by a constant step, right? Meaning what this really means, well, it means a number of things, but it means when I say constant step, that step is K. K is the number of radians per meter, right? The angular wave number. It's the number of radians per meter that we add to the phase of each next successive oscillator. So like if the first oscillator had no phase constant, if the first oscillator, say, is at position x equals 0, then it's just a cosine omega t. The first oscillator, it starts all the way at 15 centimeters below equilibrium, let's say. Then we go to the next oscillator, which is, let's say, 1 centimeter away. Remember, they're all like evenly distributed on the x-axis. So we go to the next oscillator, which is, we'll call it oscillator number 1. It's at x equals 1 centimeter. We give it a phase of, say, pi over 2 times 1, meaning it starts when the first one is at 15 centimeters below equilibrium. This next one is actually at equilibrium. It's a pi over 2 out of phase with the first one. When I say pi over 2 out of phase, I mean quarter cycle out of phase. That's an example, pi over 2. But if in my example, say K equals pi over 2 radians per meter, then that would mean when the first one is at amplitude, the next one is at equilibrium, and the next one is pi over 2 from that, right? The next one, right, is the one that's at position 2 meters. But if K is pi over 2 radians per meter, then we would multiply pi over 2 radians per meter times 2. So this next one would be a full pi out of phase with the original one at 0, right? It's pi over 2 out of phase with its neighbor, which means it's 2 pi over 2 out of phase with the original one, because it's 2 away from that, right? So it's all the way at negative amplitude, and on and on and on. If each one of these next oscillators is out of phase by an amount K radians per meter, and if each one of the oscillators is oscillating at a rate in time of omega radians per second, then what you have is oscillations in time and space, or you have cosine functions in time and space. This is a wave. Right? And I'm watching the time. We have 4 minutes, but this all, remember, go back to lab 3. I'm not saying you understood all of this then. That's when you first saw this. But now we're putting this all together and saying, if you look back at lab 3, what you noticed was if you pick any, okay, read it backwards from the bottom. Look at the very bottom thing of this whole sheet. You pick a constant value of x, like x equals x naught. In other words, you go to some position on this whole array. You looked at some position and just took the movie, watched the movie of the thing going up and down and up and down. Then y is a cosinusoidal function of t for that given x, right? Each one of these x's is a oscillator, a cosine function in time. But also in lab 3, if you just picked a particular moment in time, if you just took a photograph of the whole thing and looked at what y was doing as a function of x, it was a cosine function. So we're distributing cosines in time and in space together at the same time in the same function. This is a wave. A wave is a collection of identical oscillators staggered in phase by a constant step. right? You have to understand oscillators to understand this. You have to understand phase to understand this. But once you do, you put a bunch of oscillators together and organize them and organize their phases this way. And what you ultimately have is an immaterial motion. I'm watching the clock. What you ultimately, and I hope you understand this from lab 3 and lab 4. What this ultimately means, like if this one's going up and down while this one goes up and down and this one's going up and down, then if you stand back and watch, what you see is up downiness move horizontally, right? You'll see a crest, for example, you'll see a peak like travel horizontally along this throughout this series of oscillators. That horizontal motion, you don't just see it, you see it with your eyes and you're not being fooled. It's not a misperception. You see it. And there's an amount of space that pulse moves from one lab partner to the other. And it takes a certain amount of time. So we can calculate its velocity and we can make predictions from that. In other words, we can do physics on this bump that we watch go from one lab partner to the other. But this is, again, the key. This is why we're now having a midterm. We're finally there. The key moment in the course is that this bump that was a motion in every scientific sense of the word motion, the thing that was moving here was a bump. And what do I mean by that? I mean, all that was ever doing any kind of motion was metal. Metal was going up and down, metal was going up and down, but no piece of metal actually traveled horizontally from one lab partner to the next. The thing that went horizontally from one lab partner to the other, I mean, the thing that traveled that we call a wave pulse, we call it a wave pulse because it's not a thing. You see what I'm saying? There are individual things that are going up and down, and then they will create this motion that goes left to right. But there is no individual thing that goes left to right. What goes from left to right is information. You can call it energy if you like. You can call it all kinds of things. You can call it a wave if you like. But what we've just created with this collection of phase staggered oscillators, what we've created is wave propagation. We've created a motion of something that is immaterial, non-particle, non-particular, non-thingy thing. Okay, but you have to explain that the way I explained it in the. I mean, I just did explain it, but that's the idea that we're looking. The more you can show that you get that a wave is composed of oscillators in time and space, the more you've rocked question 4. Okay, that's 1:30. I'll hang out for a second if there's any questions, and we will do more of this next Monday because we won't put right. Okay, but thank you very much. Thank you.
Have a great day, Professor.
Great.
Have a good day, Professor.
Thank you. You too. Have a great day. Wait, I'm stopping. Or Osmail, are you there or copying, or are you there, or am I going once, going twice? Going once, going twice. Okay, going once. Going once, going twice. Goodbye.